Hi, everyone. Welcome to today's edition of the Conversations on Ocean Carbon webinar series. Today's webinar is the 12th installation of the series titled Our Coasts, Resiliency, and Carbon Removal, a California Case Study. My name is Melanie Herrera, and I'm a Senior Science Policy Fellow with the California Ocean Science Trust, or also known as OST. This webinar series aims to deliver the best available information on mCDR, or marine carbon dioxide removal, and to explore concepts related to coastal ocean carbon. OST is one of many partners that makes this webinar series possible. So thank you again to our partners, including Washington Sea Grant, the NOAA Ocean Acidification Program, California Current Acidification Network, Alaska Ocean Acidification Network, Stanford University, the Southern California Coastal Water Research Project, and the Pacific Northwest and California Current mCDR nodes. And here are the faces behind our fantastic planning team that work to create dialogue among scientists, industry members, tribes, and natural resource managers throughout the West Coast to provide a better understanding of the field of mCDR and ways to become engaged. So thank you so much to this team, and thank you all for joining us for today's webinar. We will have 5 incredible speakers joining us today to discuss the findings of a new report from the Carbon Removal Standards Initiative and to discuss the integration of mCDR into U.S. coastal infrastructure. Anu Khan will be our facilitator. We also have roadmap author Gabby Kitch with us alongside our other panelists, Joe Street from California Coastal Commission, Martha Satula with Southern California Coastal Water Research Project, and Karina Johnston, Executive Director of Heal the Ocean and representing the California Dune Science Network. So thank you so much for our speakers for joining us today and leading this discussion. Here is a quick overview of today's webinar. Our facilitator, Anu, will kick us off with remarks. We'll then hear from Gabby on an overview of the roadmap, and then we'll head into our panel discussion and Q&A. A couple logistical reminders. Attendees, you are all in listen-only mode. There is a Q&A function at the bottom of your screen, so please feel free to submit your questions there for the Q&A at the end. And please note there's also a separate chat function where you can message speakers directly if needed. And lastly, we are recording this session and we're going to share it on YouTube over the next few weeks, so you can keep an eye out for that. And we'll also add a link in the chat where you can find this webinar and past webinars. Before I kick it off to our facilitator, I'd like to warm us up with a few poll questions to help inform our future webinars and learn about you, the audience. So poll number 1 asks, what best describes your relationship with mCDR? So take a couple minutes to add in your answers. Looks like we have most folks are part of an active mCDR project. Most are also on the regulatory management policy side. And then we also have 30% not currently involved in CDR, but want to track this issue. So that's great. I'll move on to our next poll. So ending this one. And our next poll asks a similar question, but with coastal resilience. So please add in what best describes your relationship with coastal resilience. We'll just pause for a couple minutes to give you folks some time to answer. Thanks for adding in answers. It looks like we have most folks right now are on the regulatory management policy side with coastal resilience, 23%, and then we have about 15% are part of an active coastal resilience project. And then we have about 50 that's not currently involved in coastal resilience, but interested in the integrations with mCDR. So this is a really great feedback, and glad to hear that we'll be able to dive deeper into the integrations of coastal resilience and mCDR. So I'll go ahead and end that poll and launch our third one, which asks, give me one second. asks, where do you live and work? And feel free to check multiple answers if your region of focus is different from where you live or if you cover a couple different regions. Appreciate everyone participating so quickly. It looks like we have most folks from California, and a good amount of folks, 33% from other US states not listed, and 14% outside of the US. So glad to see that we have quite a bit of regional diversity, not only along the West Coast. So I will go ahead and end this poll. I have just one more until the end of the webinar. So I appreciate you guys bearing with me. Lastly, I have launched the last poll for this section which asks, do you identify with any of these communities? Feel free to select all that apply. I see responses are slowing down, so it looks like we have a really equal sort of diversity of folks representing different sectors, about 50% from academia or research. And then the next biggest one is 38% from an NGO or a nonprofit, 34% from government, and then a couple other distributions. So great to see that we have a big diverse of perspectives and backgrounds, and appreciate you all for attending. That will be the last poll for this section. And with that, I will pass it off to Anu to fully get us started, and everyone enjoy the webinar.
Hi, everyone. Thank you so much for joining us today. First and foremost, before I dive in, I want to thank Melanie and the California Ocean Science Trust for creating the space for this conversation. Very briefly, before I hand it over to Gabby to share her work on the roadmap, my name is Anu Khan. I'm the executive director of a small nonprofit called the Carbon Removal Standards Initiative, or CERSI for short, like the Game of Thrones character, which wasn't as relevant for the last few years, but I've heard Game of Thrones is back. Anywho, as many of you know, there is a broad scientific consensus reflected, for example, in the fifth and sixth IPCC assessment reports, that we need to remove carbon from the atmosphere to achieve net zero carbon emissions and eventually net negative emissions. But on current emissions trajectories, this implies billions of tons of carbon removal per year by mid-century, which is a massive undertaking and really a whole of society effort. At CERSI, we think one promising avenue to help scale carbon removal solutions is sector-specific integrations, by which I mean finding places where removal fluxes intersect with existing industries and leveraging this shared physical and policy infrastructure to achieve multiple goals. So broadly, we think integrated CDR can be an opportunity to scale a very much needed climate solution. Gabby Kitch, our speaker today, has been exploring one particularly promising type of integration, embedding abiotic marine carbon removal techniques into coastal resilience projects. Before I hand it over to Gabby to explain what that could look like, I want to quickly note that our work at CERSI and Gabby's work specifically is fully philanthropically funded. And we as an organization have no stake in the sale of carbon credits, nor do we accept funding from companies that participate directly in the sale or trading of carbon credits. So we're really fortunate to have donors that enable us to think about these big questions from a purely public benefit perspective. And that's the lens that Gabby also brings to the project she'll speak to today. And with that, over to you, Gabby.
Hi, everybody, and thank you, Anu, for the introduction. I'll just give great Melanie, you're so quick with the slides. I'm Gabby Kitch. I'm the lead author of Our Coast's Resiliency and CDR. So thank you for joining this discussion today to learn more, and especially thank you to the California Ocean Science Trust and their partners for inviting this discussion today. So to frame our panel discussion today, which I'm really excited to get to, I'm going to provide an overview presentation of the roadmap, which was financially supported by the Navigation Fund and was developed in partnership with the Carbon Removal Standards Initiative, or CERSI. The central question behind this work is whether coastal resilience infrastructure could be designed to deliver both adaptation and carbon removal benefits. Rather than building entirely new systems for carbon dioxide removal, this roadmap examines how carbon removal could be pursued as a co-benefit within projects that communities are already implementing to protect their coastlines. Next slide, please. Roughly 40% of the US population lives in coastal counties, and these regions are true economic powerhouses, generating trillions of US dollars each year. At the same time, these regions are increasingly exposed to climate hazards. Since 2018, the National Oceanic and Atmospheric Administration states that coastal states have experienced hundreds of unique billion-dollar disasters as extreme weather intensifies and sea level rise accelerates. Communities are responding by investing in coastal resilience projects designed to reduce flooding, erosion, and storm damage caused by these extreme weather events. However, while adaptation is certainly needed along our coastlines and elsewhere in the US, we must also address the root cause of climate change. So we have to mitigate climate change by reducing emissions. And as Anu mentioned in her opening remarks, this also includes removing carbon dioxide from the atmosphere. Today, these two efforts, adaptation and mitigation, often operate in parallel policy silos with separate funding streams and institutional structures. This work explores whether coastal resilience projects could serve as a bridge between these adaptation and mitigation fields. Next slide, please. This roadmap was designed based on coastal resilience practitioner feedback. So the research process included more than 40 interviews with coastal resilience practitioners across different coastal US states, along with reviewing projects, policies, funding programs, and state resilience plans. From that research, we developed criteria to identify the locations where carbon removal could physically integrate with coastal resilience infrastructure, and I'll talk a bit more about that criteria in a few slides here. And more than 20 external reviewers contributed feedback during this roadmap's development. The result is a roadmap that examines 3 coastal resilience pathways, which I'll discuss just in a moment here. And it evaluates these 3 coastal resilience pathways through various case studies. So 4 different case studies that I'll mention today before focusing in on California. It also identifies research priorities and policies that produce the enabling conditions for pilot projects for these integrations. This roadmap, as Anu mentioned, really only considers abiotic CDR, carbon dioxide removal integrations into coastal resilience projects. So I want to break those 2 terms up just a little bit before diving in. When I say abiotic, I'm really talking about processes that utilize the ocean's chemistry to draw down CO2. So in this case of the roadmap, I'm largely talking about enhancing the ocean's ability to take up CO2 by increasing what is known as alkalinity, or the ocean's natural buffering capacity here. So we'd be modulating that alkalinity. Resilience projects, the way that I've defined them here, are those that allow for communities to recover from climate pressures. And they don't necessarily include in this roadmap actions taken largely for recreational or tourism purposes along the coastline. So we're really thinking about the response to climate pressures here. And I want to note up front that this report does not provide engineering specifications or site-specific carbon removal estimates. Instead, it aims to provide the foundational step to explore where integration may be possible and what questions need to be answered as projects move into an implementation stage. Next slide, please. We can jump into our coastal resilience pathways. So the first resilience pathway I examined in the roadmap is living shorelines. So living shorelines, as I've defined them in the roadmap, are nature-based approaches to stabilizing coastlines. They often combine placing vegetation with different structural elements, such as things like oyster reefs or rock sills, or even sediment placement to reduce erosion and wave energy impacts. Those are often called the breakwater structure, as you can see here, titled Living Breakwater. These systems are increasingly used as alternatives to hardened infrastructure like seawalls, which we see often on the US coastline, because they provide shoreline protection while also preserving habitat and natural sediment dynamics. From a carbon removal perspective, living shorelines already involve placing materials such as sand and sediment in coastal environments. And because these materials are already part of the project design, there could be opportunities to substitute or supplement them with alkalinity generating materials that enhance the ocean's capacity to absorb carbon dioxide. So the roadmap explores how this existing infrastructure could incorporate those materials without fundamentally altering the resilience function of the project, and may include some co-benefits to the project, which I'll talk about at the very end of the presentation today. Next slide, please. The second pathway examined in the roadmap is ecosystem restoration. So restoration projects, many of us are largely familiar with these. We might see them happening along coastlines or in the areas that we live in often. Restoration projects aim to improve coastal habitats such as tidal marshes, or in some locations, things like seagrasses and mangroves, from a degraded state. And these habitats often have the ability to reduce wave energy and have other kind of benefits to the coastal ecosystem, like improving water quality, supporting biodiversity, and also helping to build coastal elevation through sediment accumulation. Many restoration projects already involve the placement of sediment to help ecosystems keep pace with sea level rise. So one example of this placement is called thin layer placement, where sediment is applied across marsh surfaces to maintain elevation and support vegetation growth. These projects have largely been rolled out in a pilot sense across different US coastal states. Other examples include marsh creation, where large amounts of sediment, usually something that is dredged from a nearby location, are used to create kind of new tidal ecosystems and landscapes. Because sediment placement is already part of these projects, restoration efforts may also include opportunities to incorporate alkaline materials that could increase the carbon drawdown happening in these projects. I also want to note that for ecosystem restoration in these organic rich systems along the coastline, there are geochemical processes that generate kind of natural alkalinity that could enhance carbon removal as well, making them particularly relevant environments for exploring the integration of carbon removal approaches. Next slide, please. The third pathway that is discussed in the roadmap is stormwater management infrastructure. So stormwater systems in coastal settings are designed to manage compound flooding. So this is the case where we have inland rainfall that's running off and it's interacting with tidal surge coming from the coastline. And these systems to manage kind of compound flooding and stormwater include both gray infrastructure, things like pump station, treatment plants, retention tanks, and green infrastructure like wetlands or bioswales that have been recently added to many city designs. Many projects for the resilience focus are really kind of focused on updating gray infrastructure, so making sure that the gray infrastructure is up to date and maybe includes some kind of retrofits, and adding more green infrastructure around municipalities. Stormwater infrastructure is particularly interesting because it can create these contained or semi-contained environments where water chemistry can be carefully monitored, either during the process of release to the ocean or before. So in some systems, stormwater passes through treatment processes before being discharged into coastal waters, but sometimes storms will impact that. And we'll get into some more concrete examples of what I mean when discussing the stormwater management case study for California. And all of these different processes and the treatment of stormwater can create potential opportunities to introduce alkalinity in measured and controlled ways through these systems. Next slide, please. So to illustrate how these pathways might operate in practice, the roadmap evaluates 4 different state case studies. States were selected using a weighted criteria approach to identify which states could provide a strong illustrative kind of case study here. So these weighted criteria were not made to necessarily say that these states are where integrations are most practically feasible. From my research, I really think that these integrations could be pursued across different US coastal states. However, it just gives us a way to narrow our scope and be able to highlight a number of different case studies. So these weighted criteria included things like policy frameworks, economic and geographic factors, along with exposure to coastal hazards and the institutional capacity to implement resilience projects. And I'm happy to talk more in the Q&A if people have questions about these criteria. Next slide, please. Based on the weighted criteria, the report focuses on these 4 states listed here. So Louisiana, California, North Carolina, and New Jersey. Each of these states really represents a different coastal context and governance structure that's explored in the roadmap. Louisiana highlights large-scale ecosystem restoration programs. California, which we'll talk more about today, illustrates opportunities for living shorelines and stormwater systems. North Carolina combines kind of the shoreline stabilization through living shorelines and restoration initiatives, which are both ongoing in the state. And New Jersey illustrates stormwater along with these living shoreline strategies as well. Together, these case studies demonstrate that integration opportunities may exist across a range of coastal environments. Again, these are really meant to be illustrative case studies rather than being limited to one region. So a rural coastline versus an urban coastline, really there are integration opportunities across those different places. And these case studies, like I said, are illustrative examples where there's coastal resilience infrastructure, policy support, and implementation capacity intersecting all in one space. Next slide, please. Great. So for the remainder of this talk, we'll be focusing in on California, which will include the discussion of living shorelines and stormwater management, as I mentioned in the previous slide. I also want to mention upfront here that California is a great candidate for ecosystem restoration as well. But this pathway, I chose not to explore it in the roadmap because there are other state case studies that go into ecosystem restoration in detail. So when you're looking at the roadmap and using it as a tool, hopefully for your future studies, just note that some of the different pathways may apply across states, even if they're not explicitly mentioned in one state. Next slide, please. Great. So digging into living shorelines in California, I'm going to focus really on dune systems, which play an important role as an open water kind of living shoreline feature in California. Approximately 1/4 of California's coastline is backed by dunes, and they function as a barrier between the shoreline and different coastal infrastructure along the California coast. Many of these dune systems have been degraded or eliminated through coastal development, but restoration efforts are increasing as communities work to rebuild these natural buffers, and really excited to have Karina on the panel today to talk more about dune restoration efforts. The California Coastal Dune Science Network currently tracks roughly 25 dune resilience projects across the state, which includes projects that are being implemented, underway, or in the planning stages. Thinking about the integration opportunity here for dunes, this really includes adding alkalinity-based sediment to the vegetated area of the dune. I'll explain more in detail in the next slide, but I also wanted to flag, when thinking about living shorelines in California, dunes are certainly not the only opportunity for living shorelines, and there could be other integration opportunities in more protected areas like bays, which are discussed, as I mentioned, in other areas of the roadmap, like the North Carolina and New Jersey case studies. So those certainly apply to California as well. Next slide, please. Okay, hopefully taking a little bit of a lift off of Karina's shoulders for the panel discussion here and giving my take on dune systems, and hopefully she can fill in some of the gaps that I have left. So coastal dune systems form dynamic landscapes that are shaped by wind, waves, and vegetation. Oftentimes we see pioneer dunes near the shoreline, which are frequently disturbed from tides and storms, and therefore they support kind of sparse, salt-tolerant vegetation, if any. As we move further inland in the dune ecosystem, vegetation can become a bit more dense. Of course, this is quite variable across the different geographies in California and the vast kind of expanse that the California coastline holds. But we can see vegetation cropping up in kind of some of the more mature foredunes and the back dunes. And shrubs and sometimes even forests can start to develop on the back dunes that are furthest away from any kind of shoreline or sea kind of impact here. Vegetated dunes in general could provide the conditions where soil moisture and biological activity influence soil chemistry to speed up mineral dissolution processes. So this could be an interesting environment in the vegetated dune areas to explore potential carbon removal integrations, add in that kind of alkaline sediment to these vegetated areas. So this would be more akin to what we see happening in enhanced weathering and liming of different kind of agricultural lands and things like that. Next slide, please. So to further explore integrations into dune systems in California, we have outlined a number of research priorities that we think we should be addressed as kind of the first step to move forward in the roadmap. So the first one is to establish baseline physical and geochemical conditions across California dune systems. Through my research at present, there's really a limited understanding of how soil pH or the soil acidity and carbonate chemistry vary across dune landscapes in the California coastline. So there's been studies done in other geographies, but certainly more needs to be done in California. The second priority or research question we've outlined would be to assess whether alkaline feedstocks are compatible with native dune sediments. So grain size is a really important characteristic in dune ecosystems, and understanding kind of the match to the natural sand characteristics is important, particularly for wind transport and dune morphology considerations. Building on that, researchers could also model how sediments would move under coastal wind and wave dynamics to determine whether the materials would remain in place long enough for dissolution to occur. And then the fourth one here, and the final one that we've outlined for dunes in particular, is it's important to evaluate how mineral additions might affect dune vegetation and other localities and other kind of ecosystems. Adding a alkaline addition can increase kind of the health of vegetation and soil pH. However, it's important, of course, to understand how those soil pH changes might interplay with the dune vegetation in particular. And the last research priority we outline here is really focused on kind of other living shoreline projects in California, which of course we didn't go into in this presentation, but I think it's worth mentioning that there certainly are research questions on those types of projects too. And the main one that we have called out is to quantify the sediment dynamics and existing project-specific monitoring in those other living shoreline projects. So this could include an assessment of how much sediment is being used for grading, for fill, for stabilization in California living shoreline projects in certain bays and inlets, and also can include an evaluation of the feasibility and the carbon removal of substituting or supplementing these materials with mineral-based alkalinity when incorporating into existing design and permitting frameworks. Next slide, please. Great. Moving on to stormwater management in California. This is also an opportunity in the state Cities throughout the state operate both gray and green stormwater infrastructure to manage runoff and reduce flooding risk, as we discussed earlier in the conversation. For example, San Francisco is the only major city in California that has a combined sewer and stormwater system. So here we're really thinking about the gray infrastructure in the city of San Francisco. And so a combined sewer outflow, or CSO, is listed on this slide. When functioning normally, stormwater is treated before discharge, but sometimes large storms can produce kind of a combined sewer overflow event into the coastline. So the city is really thinking about upgrading these different systems and ways to prevent these different overflow events. And as the system is being upgraded, that could be a great way to think about these different types of integrations, particularly as we talked about at the beginning, given the contained nature that many of these kind of like stormwater processes are flowing through, and opportunity for dosing and monitoring. There's also opportunities within gray infrastructure in retention systems. So infrastructure in Los Angeles has been quantified to say that they can store roughly 27 billion gallons of water under normal conditions, and they're looking to expand that capacity significantly and to be able to retain that stormwater into different systems. The tricky thing I will say with stormwater in general, which we'll get to in the research priorities, is that many of these systems are not, at least from my kind of like public research angle, have not been largely published in terms of where these retention systems exist and access to the retention system. So talk about that in the research priorities in the next slide as well. I just wanted to quickly highlight some green infrastructure opportunities, which California is looking at building out different kind of wetlands to retain stormwater as well, along with things known as bioswales, which I'm happy to explain more in detail, but they're little divots, if you will, in municipalities that include areas where stormwater can kind of collect and drain, and they usually include vegetation before going into a storm drain. So those types of green infrastructure opportunities are bound to play an increasing role in stormwater management. And as they are implemented in different municipalities, there could be ways to integrate carbon dioxide removal into those as well. The commonality between all of these different systems, so the gray and the green systems, is that they will temporarily contain water. So we talked about kind of that retention ability, which makes the system conducive to monitoring and addition of different alkaline substrates. And then, as I mentioned, retrofits and upgrades are actively being pursued. So this could be an opportunity to consider the ability to expand the public benefit of these projects by incorporating a climate mitigation technique into them. Next slide, please. Okay, to get to the research priorities, which I had been alluding to in the previous slide, the first one that I have outlined here is the inventory and the characterization of stormwater infrastructure. So this is a big one that would hopefully, be done in coordination with California municipalities to be able to map different systems, stormwater retention takes, and green infrastructure to be able to identify the opportune locations, right, that are coastal in nature, that have sufficient residence time, sufficient access points for this type of monitoring, and also maybe some operational flexibility. Stormwater by nature is episodic, so operational flexibility. There's enough flow to be able to incorporate these types of integrations. To build on that, the second priority we've listed is to model storm-driven flow regimes and residence times in California climate conditions. So really thinking about, what are the flow conditions during dry weather, moderate storms, extreme precipitation events, and those certainly vary based on the geography that you're in within the state of California. And this could then be able to refine where dosing of alkalinity, so addition of alkalinity, could be have the highest reward for investment. The third priority or research priority that we have outlined is to evaluate the material delivery strategies and the implications for monitoring, reporting, and verification. So what I mean here is really comparing mineral-based and aqueous alkalinity addition. So for mineral-based, this is explored more in the roadmap, but really thinking about solid form alkalinity, things happening in the minerals themselves. And aqueous is largely in the form of sodium hydroxide, which is produced in a different type of site and needs that infrastructure to produce sodium hydroxide. And so comparing those mineral-based techniques and the aqueous techniques across the gray and green stormwater systems to see what the dissolution efficacy is and any operational constraints and how you might monitor these different types of alkalinity additions. The fourth research priority here is really coming back to establishing baselines for stormwater geochemistry, thinking about characterizing the pH in these systems, alkalinity, et cetera, which I'm hoping maybe we can talk a little bit about in the panel as to what kind of baseline measurements are already out there. Finally, the last point I'll mention for research priorities is, of course, to assess the regulatory, operational, and public health constraints for municipal deployment. So evaluate how the proposed integrations would interact with permitting. So things like the non-pollutant discharge elimination system, also, combined sewer outflow compliance requirements and water quality standards in California. Okay, next slide, please, which will zoom a little bit back out to talk about California's policy environment, which is one of the reasons why it stands out as a potential location for these pilot integration projects. The state has robust legislation supporting both coastal resilience and climate mitigation. And so a number of these policies, certainly not an exhaustive list, is outlined here. And I'll just quickly walk through them so that you can see the diversity of the policy landscape in California. For adaptation planning, Senate Bill 1 provides funding for local governments in coastal zones and along San Francisco Bay shoreline to develop sea level rise adaptation plans. And then this is coupled with Senate Bill 272, which requires plans to be submitted for approval and likely has some funding implications for these approved plans and those that are in the policy landscape. And California can certainly comment more in depth on that. California is also creating financing mechanisms through a number of different catalyzing bills. So they have a bill known as the Climate Resilience Districts, which allows local governments to establish fees or taxes, which can then be used for resilience projects. They also have laws that have enabled different transportation initiatives, like SB Senate Bill 198, which funds local agencies to identify climate vulnerabilities, specifically to infrastructure, and create adaptation plans to combat those vulnerabilities. And then there's things like Proposition 4, which created a $10 billion climate bond and aims to fund climate adaptation and resilience initiatives. Quickly to go through the mitigation side of things, just a few quick highlights here. I really want to highlight Assembly Bill 1279, which requires California to achieve net negative emissions after 2045, which is probably the most ambitious climate mitigation or climate target bill in coastal states. And it really does indicate that the state will have to ultimately rely on carbon dioxide removal to address remaining emissions, maybe about 15% of those emissions. This is coupled with the state's Cap and Invest program, which has been longstanding to think about kind of overall carbon accounting for the state. And then other frameworks are now cropping up, such as Senate Bill 905, which has directed the California Air Resources Board to build a carbon management framework and largely, broadly defines carbon dioxide removal. And there's many other recent bills that haven't necessarily been signed into law that speak to carbon dioxide removal and carbon management. So there's certainly a level of interest among California policymakers on this topic. I also will note, since I don't have time today, the roadmap does present a section that talks about coastal resilience permitting processes, from, not a permitting, just my research point of view. So that might be of interest to you if you're interested in thinking about how to pursue these kind of pilot integrations, but I will leave that for your own perusal at your leisure. Next slide, please. Okay, so to quickly wrap up here, one important insight from this roadmap work is that integrating carbon dioxide removal into coastal resilience projects could strengthen much needed monitoring programs for coastal management more broadly. So coastal resilience projects routinely track, and our experts can certainly comment on this, things like shoreline changes, hydrology, ecosystem health. Carbon removal projects require, of course, for carbon accounting, monitoring, reporting, and verification to assess how the carbon is being removed and how ecosystems respond. So by integrating this kind of stringent monitoring into resilience projects, we can not only include a more robust suite of measurements for resilience projects, but we can also include some standardization to those existing monitoring programs. This could perhaps improve data consistency across programs and projects, and enable comparisons between different approaches, also increase transparency about environmental outcomes. These integrations can also create opportunities for learning across both fields. So for the carbon removal community, pilot projects embedded in resilience infrastructure can help refine frameworks, modeling tools, environmental monitoring approaches. The ability to have more projects in the field is certainly a priority for the carbon dioxide removal sector. And for coastal resilience practitioner, like I mentioned, the additional monitoring and data collection could improve future coastal restoration projects, shoreline protection strategies, and stormwater management systems. So to move these integrations forward, the roadmap covers a number of key steps, and certainly I didn't have time to walk through all of those here, so I welcome you to go look at the roadmap and all the specific calls to action for different groups. One is developing pilot projects that integrate with existing resilience monitoring programs. The second is to adapt existing carbon removal protocols, those that are largely built for enhanced weathering or ocean alkalinity enhancement for coastal resilience projects. And finally, to make all of those goals happen, this will really require a stronger collaboration between carbon removal researchers and coastal resilience practitioners, so that the communities can design projects that do meet resilience goals while furthering climate mitigation efforts. Okay, last slide, please, Melanie. Thank you. So the central takeaway from this work is that adaptation and mitigation do not necessarily need to remain separate climate strategies. Coastal resilience infrastructure is already being planned, funded, and constructed to protect communities from climate impacts. And if thoughtfully designed, these projects could provide opportunities to remove carbon from the atmosphere. So embedding carbon removal within resilience infrastructure can strengthen environmental monitoring, could diversify sediment supply chains, and can extend the value of these publicly funded adaptation projects. The roadmap provides much more detail on the case studies, research priorities, and implementation considerations for those that are interested in diving in a bit deeper. For now, thank you for your interest, and I'm excited to get into the panel discussion. So if I could have all panelists turn on their cameras at this time, and I'll pass it back to Anu.
Awesome. Thanks so much, Gabby. Before we dive into the panel discussion, I just wanted to give a huge shout out to Gabby for her work on this roadmap. We've had the chance to work together over the last year, and it's just been fantastic. And I'm excited to dig in specifically on California, as Gabby mentioned, a leader in climate policy, but also carbon removal policy specifically. So really exciting. Before we dive into the panel, I just want to quickly ask Gabby a follow-up question. A few folks have asked in the Q&A How do you think about the carbon removal potential of integrations? What do we know about that? Do you want to just super briefly speak to that before we dive in?
Sure, yeah. So the potential for these integrations, I see it in a number of different ways. Certainly, some of these different pathways have potential to scale. Like I said, I didn't necessarily run the numbers on the scaling potential, and hopefully that can be a follow-up to this roadmap. Things like ecosystem restoration and even potentially stormwater management that have large infrastructure and large swaths of land. For living shorelines, of course, projects might be a little bit more segmented, which has complications when it comes to scale. However, let's back up for a moment here and think about the potential for ocean alkalinity enhancement to scale overall. And it's a very scalable potential solution in the carbon dioxide removal space. And so these projects certainly would have learnings and be able to transfer knowledge into the greater ocean alkalinity enhancement field as well.
Awesome. Yeah, I was going to double click on those points that Gabby raised as well, that we're doing a separate study at CERC about the potential of integrations across all integrations. So if you're looking for those kind of early estimates, we'll have more to say about that soon. And then just to reiterate, as Gabby said, a lot of the value of integrations is near-term deployment and learning, right? So what can we learn from projects that are already kind of in progress? With that, I want to of course, switch gears to our moderated panel discussion, and that will be followed by an audience Q&A. So please do keep the questions coming in the Q&A box. For our panelists, I'd love if you could just share a quick 3-sentence intro about yourself and where you sit in the coastal resilience conversation in California today. And maybe Joe, you could start us off.
Sure, happy to. Hi, folks. My name is Joe Street. I am the manager of the Coastal Commission's Energy, Ocean Resources, and Federal Consistency Division. I've been with the commission a long time and previously was their staff geologist. In a former life, I was a researcher and grad student in biogeochemistry and paleoclimatology, so I'm not completely ignorant of the topics we're talking about today, although some of that knowledge is out of date and is being overwritten by all sorts of policy considerations. So happy to be here.
Awesome. Martha?
Good morning. My name is Martha Satula. I'm the head of the Biogeochemistry Department at the Southern California Coastal Water Research Project. And SQUIRP, that's the acronym for my research institute, is essentially an institute that focuses on translating science to improved management of coastal water quality and natural resources. And then my particular experience has really been focused around topics like climate change and eutrophication, how we can improve resiliency from a coastal water quality perspective.
Awesome. Thank you so much. SQUIRP is a fantastic acronym, by the way. So when Gabby first was like, I thought CERC was good, but SQUIRP is fantastic. And Karina, over to you.
Yeah, my acronym isn't as cool. I am Karina Johnston. I am the executive director for Heal the Ocean. We are a Santa Barbara County-based nonprofit organization focused on ocean health and coastal resilience and pollution prevention. And my other hats are as a PhD candidate for the University of California, Santa Barbara in the Marine Science Institute, studying coastal dune systems for their ability to provide coastal resilience, especially flood protection. And I'm also an advisor for the California Dune Science Network. So I'll post the link to that group in the chat. Any of you who are attending from California, we would love to have you join our newsletter.
Awesome. So just give a little bit of context setting for what we're hoping to kind of surface through this discussion. As Gabby mentioned, we're really trying to bridge knowledge gaps between the abiotic marine carbon removal community and the coastal resilience community. And of course, our panelists have a lot of expertise in coastal resilience broadly. And so my first question for you all, feel free to jump in. Given your vantage point in the California ocean science and coastal resilience community, what is the coastal resilience conversation like today? Are there any, sort of like big topics that are coming up? Are there any contentious issues that we should keep in mind as we think about these integrations? Really just kind of what are you seeing in this conversation today? Martha, maybe I'll
Gosh.
pick on you to start to break the ice.
Well, I think that the answer to that question probably really depends on, to some degree, on discipline, because even though we talk about coastal resilience, if you try to answer that question, and I'm going to guess that Karina will, from a restoration perspective, the way that you would think about that is quite different than how we think about stormwater management or even wastewater management and the resilience and how that community needs to think about resilience because they're thinking about infrastructure, they're thinking about protection of water resources, making sure that humans have enough water resources to persist. And so then I think a lot of the questions about how do we balance and what choices do we make, then I think the difficulty that we face is the ways in which these conversations can be siloed. And so this is essentially what you're trying to tackle today, is trying to merge a conversation around mCDR with coastal resilience. And I think that then the challenge is how to effectively break down those silos among the communities. And that's an interesting one in California. California is a complicated regulatory environment, a complicated geopolitical environment. And so I think that that's a formidable challenge.
A quick follow-up. What would you say are the biggest silos when you say like the conversation's pretty sad? What are some of the big ones that you see as like this community's kind of got its own spaces, this community's got its own spaces?
Yeah, I think that one of the biggest silos are the regulatory framings around it. And so then, just for example, let's just say that you're a county stormwater manager, and you've got probably a half a dozen to a dozen permits that you have to comply with. And so if someone's going to be knocking on the door of a stormwater manager and kind of offering, then I think that the difficulty is really starting to provide a clear set of incentives as well as regulatory relief that would really help to start to break down some of those silos. And, for that person who would be in charge of doing such a thing to really feel like that would be a temptation to actually take it on, because their day jobs are really tough. That's my 2 cents.
Karina, were you gonna chime in here as well?
I was just wondering if Joe wanted to respond to Martha's comments about regulatory challenges.
No, I think those are a lot of really fair points, and I think I would add that in the marine CDR space in particular, I think the regulatory community is just beginning to understand what's going on and even think about how it might fit into our existing, regulatory frameworks and pathways. So I think we're playing catch up, and that's going to be really important as people move forward with projects. I think on a potentially more positive side, I'm thinking mostly about the outer coast, high energy environments, the kind of areas where I work in mostly. I think we're in a kind of interesting transitional phase with regard to coastal resiliency in general, in that, we've had a few cycles of pilot projects and small to medium scale coastal resiliency projects spanning, from, interesting hybrid projects, dune, buried rock type projects like the Cardiff Living Shoreline or Surfers Point in Ventura. And some of these projects have been around for a little while now and have had, multiple years of data collection and have been through some, tests in terms of, major coastal storms. And we're starting to get data and understand how well these perform. And many of them do perform really well in terms of their both, they're kind of dual goals of providing storm protection and providing, ecosystem benefits. So I think we're kind of at a point where people are starting to think about how they can build resilience projects into coastal planning over the long term on larger scales and integrating them with kind of the traditional techniques that still are by volume and dollars the dominant ways in which coastal management occurs. For example, beach nourishment. For example, building armoring for structures that are protected. So I think there's an opportunity here, both just within resilience to come up with new and innovative projects, but also to add things like um, carbon dioxide removal. So I'm interested to see what ideas come out of it.
Yeah, I can follow on that. That's a good segue. I want to circle it back around to coastal habitat restoration. So, when we think about the idea of coastal resilience, a lot of people think about sea level rise or flooding. Coastal resilience, in my mind, can be defined in a couple of different facets. One is the ability to resist disturbance, in this case, potentially from flooding, and one is sort of adapt or respond to that disturbance. And I think when we think about coastal ecosystems, there's a lot of opportunity to mimic or replicate natural systems and their ability to provide these that type of benefit. We're really, I think, engaged where we are in the space is that I think we're really engaged in this kind of multi-benefit conversation. So I'm really interested to see where today goes and some of the data gaps that might need to be filled, which I think Gabby highlighted a few of them. So I think those will be interesting discussion points. But the ability for these systems, coastal dunes, coastal wetlands, other habitat types to provide this buffer from sea level rise and flooding is, I think, a really important value that I just want to emphasize. In California, we have this really incredible latitudinal gradient across our coastline. We have 1,600 kilometers of coastline, and the diversity of the systems across that gradient is huge. There are different species, different meteorological patterns and rainfall, different wave energy, and even within those systems is a lot of variability. And so I think there's an opportunity here to kind of expand on that research. I'm part of a statewide coastal dune research team led by UCSB, trying to answer a number of those questions, some of which I think interrelate to our panel topics today, but others where we're kind of identifying what some of those gradients are, what some of the challenges are, the variability within the systems um, is high, and tying the kind of localized coastal dune dynamics, the geomorphology, the form and function with vegetation type, whether they're invasive species there, all of that affects the soil chemistry, and there are a number of unknowns kind of within that space. So that's, I think, worth exploring a little bit more too. But I think these systems in general, in the space that we're in now, we have, as Joe mentioned, a number of successful pilot projects across a gradient of adaptation types and spectrum. And so we have, on one end, natural restorations of coastal habitats like dunes or wetlands. California has lost an area about 60% of our dunes, and that's especially coastal dunes, and that's especially prevalent in areas of Southern California that have lost more than 95%. And so gaining back some of this function from a multi-benefit perspective and the ability of these systems to sequester carbon and provide other benefits is really high. So just kind of circling around to that space, I think we have successful pilot projects, and we're starting the conversations now about scalability. And I think that's where both the regulatory perspective, the local municipalities and implementers of the projects are heading.
Yeah, absolutely. Um, One of the themes that I'm hearing, particularly Joe and Karina across your comments, is innovation in coastal resilience, embedding in coastal planning is something that's kind of an ongoing conversation and finding mutual benefit projects there. And now we're kind of doing like the next layer of integration of can carbon removal and carbon sequestration be a co-benefit or something that can be integrated in there. So there's a lot of opportunity for innovation and sort of mutual benefit identification. One thing that comes up is kind of, Joe, from your regulatory perspective, having seen the report, if someone comes to you with a project that has an mCDR
Mhm.
integration, what are some of the questions that immediately pop up for you? What do you want to know? What's some of the data that you would want to see?
Well, so I mean, just to back up a little bit, I think it's an important point to make that, people have mentioned that there's regulatory complexity. And I think on the ground, what that kind of means is that there's going to be multiple local, state, and federal regulators that are likely going to need to provide some sort of permit or approval for any given project. It will depend a lot on what type of project we're talking about and where it's located. But, and, I know there's a lot of coastal management and policy people in the audience, so I'm going to probably run roughshod over um, things that you know much better than I do. But I think it's probably fair to say that this perspective or standpoint of many regulators, and this is based on the legislation that we operate under, a lot of it coming from the 1970s, is first and foremost, we're looking at impacts and effects. And the perspective is often, Hippocratic, so to speak, and that first do no harm, first maintain what you have. So it's kind of it's looking at that rather than looking forward always in terms of what the project, the good or the benefit that a project intends to do. So information is key. The more project and site specific information that you can come in with to present to a regulator in order to get a permit, the better your chances of having a smooth process. So, and again, it depends on the type of project, but we really need to know what the potential effects on biological resources are, or on soil chemistry that could then affect um, how sensitive species in a dune system might respond. Um, what it means to add alkalinity to a waste stream and then send it out into the ocean, what it means for local and regional biological productivity if you're going to take in a large amount of seawater in order to add a substance to it in order to, achieve a carbon dioxide removal objective. All these things are the types of impacts and effects based information that regulators are going to need to know. And based on the presentation that Gabby gave, a lot of these things are still open questions and are topics of research. So to my mind, a really practical approach is to scale up from small scale research into pilot projects and into, gradually increase towards, full scale projects, gathering information as we go.
Yeah, that makes a lot of sense. And I think you mentioned a couple of times sort of in the resilience space, moving from pilots to small to medium projects. Could you give us just a quick calibration for what size is a pilot, what size is a small to medium project? Super easy question, I'm sure.
Oh gosh, I mean, it's a continuum, I think, right? So I guess to my mind, a pilot project is one that can be implemented, in vivo, what's in situ, on the ground in the environment, but at a scale at which any potential impacts to existing resources are below a certain threshold of significance, just because of the scale of the project. Um, and
I would just
that's a really key cutoff for a lot of regulators is significance.
I would just add to that that it's very geographically dependent and site specific context dependent. Um, a pilot project somewhere like the Vandenberg Space Force Base um, outside of Lompoc is uh, of a different scale than something on an urban beach in Southern California, which might be much smaller. Just for context, for the kind of regulatory intersection, I implemented a project, dune restoration project that was really just adding native plant seeds to the beach in LA. And there was a nexus with 6 different agencies. And that is, I think, just an example of speaking to the regulatory complexity for California.
Yeah.
So
Yeah.
what I would probably want to be able to add on to that is that I feel like, where you see a lot of energy and acceptance, in this coastal resilience space is really on nature-based solutions. And so if you're talking about abiotic mCDR, I think, in addition to what Joe said, I would really call out that I think that there's a need for education and some basic documentation. Basically, can you pass the LAF test through a clear MRV plan that would essentially, make it clear that if you're going to undertake, this integration, that you're actually really going to be achieving carbon dioxide removal. And I think that was a big point of discussion in previous workshops that we've had about integrating, mCDR, and how do we kind of confront, water quality and different types of regulators, as they had that as one of their number one questions. Is this really going to give us a big bang for the buck? And then what are the impacts? I think that's the other kind of piece of what Joe had called out.
And just to follow up on the impacts, I think the sort of baseline understanding is still missing a little bit. There's a lot of questions, and I have to preface this by saying I'm an ecologist, not a biogeochemist. But the understanding of some of the soil chemistry questions and things like that associated with coastal dunes, existing potential for carbon sequestration just through natural restoration is, I think, still poorly understood for California in many ways. And so I think there's potential to integrate some of the research questions that already exist out there with some of these questions and or kind of, you know, questions about additives. I think there's differences even that exist from a soil chemistry perspective in native dunes versus those that are covered in a invasive species like Ammophila or European beach grass or um, ice plant, tending to make the soils more acidic and those types of questions that could be delved into further too.
Yeah. Um, Gabby, I want to bring you back into the conversation because I think both Karina and Martha mentioned we want to know that there's carbon sequestration happening in these projects. It's going to be a dual benefit, and there's quite a few open questions about that. So, from the report, but also generally from your background and expertise, what kind of monitoring would we need for the mCDR portion of these projects?
Yeah, and I think, of course, as everybody has said, it's going to be very project specific and site specific as to what you would want to monitor. So if we take the dune example for instance, you certainly would want, or actually let's back up and take any kind of any situation, something that I think many are familiar with that are in this marine carbon dioxide world, is that you need to have an understanding of the baseline conditions. So the points that Karina was mentioning in the dune ecosystems, where there's a lot of unknowns around soil pH and the background kind of sequestration of carbon that's happening in natural dune systems, certainly want to quantify that, largely in those systems, probably through sediment analysis or, taking soil cores and things like that and understanding those types of things. And then in, the stormwater systems, that would be certainly collecting water samples and the baseline conditions, and also during an intervention, and to quantify the carbonate system, which, you need two parameters to quantify the carbonate system, not to get too into chemistry. And so thinking about measuring things like pH, alkalinity, likely to constrain the full system. And then, of course, so the way that we've outlined it in the roadmap and the way that the conversation's happening in the community, there's the carbon accounting kind of conversation, and then there's the environmental monitoring conversation. And so you would want to build out a framework where you're assessing both the carbon dynamics and what's happening with the ecosystem function. For dune landscapes, that could be things that are, Karina, you could probably talk more extensively about the ecological processes that you look at for kind of ecosystem health and plant health in those dune systems. So you can imagine those types of measurements and yeah, but there are great frameworks and resources in the roadmap as well that really dive in deep to these different monitoring components.
Yeah. So Karina, I was hoping to kind of like make this feel specific for folks who are thinking about like what does this integration look like. So I'm curious from your perspective, you've developed dune projects and restoration projects. If someone from the mCDR field approached you and they're like, hey, we think there's a dual benefit opportunity here. Here's how we might think about the carbon sequestration measurements. What are some of the questions you would have? What are some of the things that you would want to know going into a conversation like that?
Yeah, I think well, the roadmap provides some really helpful information and context. I think I think there's a lot of questions that either could be answered experimentally or from a kind of co-benefit type of query. But the to answer that, I want to circle back around to my point of the kind of diversity and variability of dunes, and also to emphasize how dynamic coastal dunes are, especially foredunes. They're altered by wind and waves. Their form and function evolves over time. They can grow over time, given the right sand budget and fetch distance and all of those kind of geomorphic considerations too. And so I think, you know, pilot testing something like this would be interesting. The first sort of questions that I might answer would relate to existing conditions for natural or reference systems kind of surrounding or nearby. Um, those aren't always easy to find, especially in Southern California. But understanding the kind of baseline context for some of the natural systems as close as you can get geographically would be, I think, comparatively something that would help inform the potential to have these additives. The other thing to consider isn't just kind of geographic location, but also position relative to the ocean. Four dune systems, very dynamic, sparsely vegetated. They're used to disturbance. As you move, as Gabby mentioned in her graphic, actually, that Zuma graphic you did was for one of my dune restoration projects in LA. Wasn't sure if I said she found it. That's great. But the as you move inland and away from the ocean and some of those, kind of salt spray dynamics and different wind conditions, you get a whole different kind of community of vegetation in the back dunes. And so the differences kind of within a site, even just sort of perpendicular to the ocean front, is, I think, a really important consideration. Definitely should be considered as part of experimental design. But again, that strength coming from really understanding the existing soil characteristics and how that would alter. And Joe mentioned this, I think, also the potential impacts for species. A lot of our coastline has been developed in California, similarly to many other states. And with that loss of a number of species, fish, birds, plants. And so all of those kind of integrations and questions that I would relate to are, what does that look like for the ecology of the system? would the additives still mimic a natural system? Would it alter, Gabby, you mentioned the kind of grain size characteristics, and it's not just size, it's shape, color, weight, rugosity, like there's a lot of, I think, again, um, kind of intricacies in that. And so it might be nice to have some really small scale experimental considerations, but after we have this good understanding of kind of the baseline characteristics.
Yeah. I'm curious if Joe, Martha, if you want to speak also to sort of I think this is true in mCDR certainly, and Gabby had mentioned this with the baselining in order to then ask anything about a potential intervention. It's true across open system CDR as well. We've been doing a lot of work on agricultural systems and soil variability. Once you start digging into it, you're like, no part of the field is the same as another part of the field. I'm curious, Joe, Martha, if there's anything you want to add in terms of how we should think about getting the data to address the sort of variability and baselining question, because it seems pretty core to the underlying challenge here.
Yeah, I guess, I would really almost approach this paradigm from a completely different perspective, which is where are the opportunities in which there is not so much variability? And I know that that is actually kind of a challenging way to think about it, but anytime we start kind of talking about site specific, then we almost go down a rabbit hole, because then any regulator is basically going to be expecting, whoever walks in the door is going to have data, that you're proving that you're not having an impact. And quite frankly, that's very challenging to do. And so I'm just wondering, are there other opportunities in which and in which we're looking for the integrations, that like maybe more targeted towards infrastructure or maintenance and the resilience in navigation. So here's an example. Can we integrate this type of approach with dredging? And what do we do with dredge spoils? So any even wetland restoration projects occasionally require dredging. Maintenance of navigation in ports. What happens to those sediments? Sometimes they're actually put back onto beaches for beach replenishment. But then what you're talking about is identifying whether or not you're altering the characteristics of the dredge spoils in any way that could actually cause harm. And there's already a lot of attention around the chemical and physical characteristics of those dredge spoils. So that's a really good example of where we're not actually really trying to integrate it with something in which we're also at the same time striving to protect and promote biodiversity. Right. So the number of things that you're trying to account for may end up making it simpler for you. Another example is, when we talk about stormwater, that's almost a misnomer. Like, we're really managing freshwater resources. And so instead of picking, the time periods in which it's storming, in which there's all sorts of variability, and that would be very hard to dose, you may actually want to pick time periods in which you have base flow, and that base flow is really sustained by, for example, effluent from wastewater treatment, right? In which case, then if you have an effluent dominated stream, then maybe what you're really sort of thinking about is, can you engineer the water chemistry so that it's essentially within a tolerance of natural variability of the organisms that are going to experience that? And that's something that the folks that are discharging to that stream already have to worry about. So that integration and thinking about those opportunities in which the paradigm is simpler, I would probably lead with those as those pilot projects in order to just see what sort of traction you actually do have. Don't choose the most complicated examples to begin with.
Joe, did you want to chime in here as well?
No, that's okay. I agree with much of what Martha said.
Yeah. And I really appreciate this point of sort of choosing those places where it's simpler and the integration might we might be able to simplify the set of things that we need to be looking at. Are there any other examples, Joe, Karina, that come to mind for that kind of integration, similar to what Martha was describing?
Well, I would say that in general, from a regulatory perspective, it's probably going to be a lot easier to get through the process if you're building your mCDR component into, as Martha said, an existing effort that's occurring in a place that's already altered or actively managed. In, say, the dune realm, a place where dunes have been paved over, bulldozed years ago, and say somewhere along the Southern California coastline, and there's an effort to restore them. By adding your mCDR component, you're not altering an existing resource, existing sensitive resource, such as a dune habitat that might be, inhabited by an endangered species. It's just there's fewer concerns, there's more opportunities to test different strategies without, affecting certain types of resources. I kind of lost track of what I was actually asked, but that was kind of following up on what Martha was talking about.
That makes a lot of sense. Um, I've been kind of integrating the audience Q&A as we go along, but one specific audience Q&A that I wanted to make sure that we touched on, and we'll do a few more of these before we wrap. One of the early questions we got was about monetizing the carbon removal aspect of these projects and kind of some of the trade-offs there. And I'm curious if anyone would want to speak to that, either from the regulatory perspective, like if there's a commercial element, how does that impact how you think about it, but really any perspective.
I can chime in up first, specifically since this question talks about the interviewee's perception on monetizing carbon removal. I think that there was a mixed kind of crowd in terms of seeing the potential benefit to be able to monetize any carbon dioxide removal coming from these different projects. I think particularly in California, some of the folks that were familiar with the budding legislation around maybe creating kind of a carbon market and things like that were excited by the potential to have projects in California that could then feed into kind of a more public driver of a carbon market in the state. In terms of the voluntary carbon markets, I think most of the interviewees that I spoke to who were interested in pursuing or seeing these integrations did so from largely the public benefit angle. So municipalities who are thinking about meeting their climate targets, specifically, there were a number within the state of California that were working at the city level, thinking about, innovative ways that they could meet climate targets, that they could, increase that kind of climate benefit for their constituents and their public.
I think what I want to say about this question is that I think that my general impression is that what's facing the restoration communities in terms of coastal resilience, what's facing the stormwater community in terms of meeting the even existing regulations around bacteria, all of this stuff is incredibly expensive. And so if there's a way to leverage and provide resources to them so that they're able to do more restoration or do more stormwater management or meet their water quality objectives, that's a win-win, right? And so if there's a real opportunity to leverage resources of the carbon crediting, and that would actually really help to accelerate other aspects of coastal resilience, I think that that's a really good incentive in general. I think the problem that we're going to have, and this is what's already facing a lot of companies in California, is just the lack of regulatory certainty. So that if you're MCDR startup, you've got a certain amount of investor funding, but then it takes the regulatory community 3 years to get you an answer. Whether or not they're going to let this proceed, that becomes really difficult for them to choose California as a place that they want to kind of try out their technologies or try out this integration. So somehow thinking about how are we going to modify the regulatory landscape, if we really want this to happen, we're going to have to think more comprehensively about the integration that has to occur. And this has to come from the governor's office to really start to simplify that regulatory landscape, clarify the pathways for how people are allowed to get permits, to try out, to do field trials, to encourage stormwater managers or wastewater or restoration practitioners to integrate with mCDR. A lot of that has to be really, I think, to make it work in California, it's going to have to be top down.
I would argue that that is one pathway
Mm-hmm.
to get there. And not on mCDR, or even on coastal resilience, but it's really difficult to change existing laws, at least in the current political climate. It's cumbersome to even change regulations, and regulations can only go so far because they have to be consistent with the existing laws that govern our regulatory landscape. So at least in recent years, I think a lot of the progress in process has come more informally, honestly, through agencies making and stakeholders making concerted efforts to coordinate better and get out in front of issues. One example of that is in Southern California for many years, and now also in Northern California, there's been interagency teams that are coordinating on staff time to do kind of pre-project, pre-application submittal reviews of dredging and beach nourishment projects, to provide upfront input to help guide projects while they're in the design phase, before they've submitted their applications, before they've committed all their resources and time to a particular design or idea, with the idea of trying to make this all more streamlined, more cost effective, and hopefully also more protective of resources. So I think there's ways of doing it, but it does require a lot of effort and legwork. So I think you can go bottom up. I think you can go top down, but both are hard.
I appreciate the segue, Joe, because the last question I wanted to ask very briefly, Karina and Martha, if you want to add a few notes here. This is definitely going to be an effort that requires coordination across disciplines and communities. So any last piece of advice that you would share with folks who might be interested in integrated mCDR projects on effective coordination?
Short answer is partnerships and willing land managers and owners. And then I think you establish enough baseline of the research to establish kind of that trust and the potential for experimental approach. And you really have to find the right partners with folks who are excited about the potential.
Awesome. And Martha, last thoughts on coordination?
Yeah, so I like Karina's answer, and I would just add to that if there's a mCDR kind of pathway in which you're trying to kind of move forward, then don't be afraid of working together within that a sort of working group that in order to develop materials that you need to educate people. What does MRV look like? What are the potential pathways of biological effects? Really kind of work together to develop a package of information rather than every company going solo and trying to do it on your own. So, work together in order to develop what you need to engage the community, because you're going to need, a lot of different types of things, and that can be rather costly. So working together is an excellent idea.
Awesome. Thanks so much. With that, I want to thank our excellent panelists. I think we could keep going for a while. I like 30 other questions I have, but we are almost at time, and I want to hand it back to Melanie to close us out.
Thank you so much for such an engaging discussion. I think that last question is a really good segue into this last poll I want to launch. Just looking forward and really wanting to get our audience thoughts on now that we've heard from Gabby and the roadmap and from our excellent panelists, what do you guys see as the biggest barrier to integrating mCDR into coastal resilience projects? We had such a robust discussion. I'm really curious how things landed with folks and what folks are thinking about in terms of next steps. So take a few seconds to answer that poll. It looks like responses are slowing down, and I'm seeing a lot of votes for permitting and regulatory uncertainty, lack of funding or incentives, a little bit for environmental and ecosystem risk concerns. So I appreciate that. Feel free to keep your answers coming in while I close out. Thank you again to our speakers and for our audience for joining. On behalf of OST and our partners, we really appreciated this deep dive into the world of mCDR and coastal resilience. A recording of this webinar will be emailed out and made available online, so you can find the recording and past webinars on YouTube, and we've added a link to the chat. I'll go ahead and end the poll now since it looks like it slowed down. And if you're interested in more regional conversations like this or opportunities to collaborate, please reach out to any of our speakers or any of our partners and stay tuned for more webinars around mCDR. Thank you so much again. Enjoy the rest of your day.
Bye-bye, you guys. Thank you.